Hello, ladies and gentlemen. Welcome back. This is for students who are in Algebra 2 Goal 3 as I continue to mysteriously do this backwards. I have 4 topics on the docket today. This is assuming that you have done your basic negative exponent list of topics. So, quick reminder, if you have a negative exponent, that means basically that you are flipping your fraction. That's what we're trying to get you used to. So what's going to happen is if I zoom in over here and I see a whole bunch of negative exponents, what I want to do is get them where they're supposed to be to begin with. So that way I don't have to worry about it because nobody's overly comfortable dealing with negative numbers, so we want to fix that while we can. So it's 7, w to the 9th goes underneath, u to the 8th goes underneath. We have a w cubed, we have a 4, we have a u to the 8th, we have a 3, and then we have a y to the 6th, and we have a y. Having done that and splitting us up, we're actually visually in a much better place. Because let's see here, we have our 7 and our 4 and our 8. So 4 times 3 is 12, 12 times 7 is 84. So far so good. Then we have a u to the 8th and a u to the 8th. Since they're above each other, they cancel out to 0, which means they completely disappear. You have w to the 3rd and w to the 9th. 3 minus 9 is negative 6, so w to the 6th stays underneath. Then we have y and y to the 6th. 1 minus 6 is negative 5, so y to the 5th stays underneath. That's what they're looking for the product rule. They're getting you used to flipping your fractions first and then doing your computation. So let's see here. Set ourselves up again. We have 3, we have y to the 5th, we have times 4, we have x to the 6th, we have 7, v to the 7th, we have v to the negative 3, we have x, and then we have y to the 4th. Now, I'm not making it a perfect one-to-one ratio, but if I happen to see some letters that are the same, I'm setting them up ahead of time. Oops. I'm setting them up ahead of time so that I don't have to go hunting for them like I did over here. So 3 times 4 is 12. 12 times 7 is 84 again. We have an x to the 6th and an x. That's on the same side of the fraction bar, which means we add them. 6 plus 1 is 7. We have a v to the 3rd and a 7th. That's subtraction. 7 minus 3 is v to the 4th. And then we have a y and we have a y. Those are on the same side, so we add them, and that will be y to the 9th. And once you've done the flipping, after you do the canceling, everything susses out pretty clearly. 2 more examples, and then we'll move on. Let's see here. We have what? We have 7. We have w to the 9th. We have u to the 8th. We have w to the 3rd. That goes on top. Then it's 4 u to the 8th. Then we have 3, y to the 6th, and then y. Okay, is this the same thing? It's the same. How are my screen grabs always being the same thing? Okay, so anyway, u to the 8th and u to the 8th cancels out. 4 times 3 times 7 is going to be 84. The w's cancels out to be w to the 6th. The y's cancels out to be y to the 5th, as I apparently just stated up here. Boo. All right, next up, we have 2u y to the 2, because that's negative. Then we have 6. We have v to the 9, that's underneath. We have v to the 7th. We have y to the 3rd. And then we have 4, and then u to the 8th. Okay, so y squared and y to the 3rd cancels out because 3 and 2, oh, wait, forget what I just said. I did it out of order, sorry. So 2 times 6 times 4 is 12 times 4, which is 48. So those are done. Let's see here. Now we can talk about the y's. We have y to the 2nd and y to the 3rd. 3 minus 2 is just 1y. We have v to the 7th and v to the 9th. 7 minus 9 is negative 2, so that v stays underneath. And then we have a u and a u to the 8th. That's u to the 9th over. So this is where, if you're not careful with your organization, it doesn't take much for you to start to lose track. So always be very, very careful of that. Next topic, let's see here. Let's do some quotient rules, so long as we're talking about fraction bars. So we're going to zoom in a little bit again. There we go. Again, negative exponents, negative exponents means you flip your fraction. You flip your fraction. So anytime I see some kind of negative exponent, I'm going to go through the effort of flipping where it is. So that becomes x to the 9th over x to the 3rd. 9 minus 3 is x to the 6th. Maybe I should have led with this one. Let's see here. We have negative 7. Flip where that is. So that becomes y to the 9th times y to the 7th. Since they're all in the same line, I add them. So 9 plus 7 is y to the 16th. Next up, this again, it's negative, so we want to flip where it is. So that's p to the 7th times p to the 7th, which is p to the 7 plus 7, which is 14. And you're starting to realize that these are going by pretty fast. If your mental math skills are strong, that makes this even easier. So negative 6 comes up, so it's x times x to the 6th, which is x to the 7th, because that's an invisible 1. Next up, this now is in the wrong spot, so that goes underneath. So what happens, do we recall, what's the placeholder that goes there when you don't have anything in the numerator? I heard somebody say it, a 1. So that's 1 over x to the 5 plus 6, which is 11. Z is in the wrong spot, or z to the negative 7. So that becomes z times z to the 7th, which is just z to the 1 plus 7, which is z to the 8th. And it gets you used to and comfortable with flipping your fractions and then doing your computation. And that's the habit that you want to get into. Next up, power of a power. This is one of the rare ones where I actually want you to do your multiplication first. So when we do the, So negative 5 times negative 4 is positive 20. Because again, power times a power. So if you have a power to a power, that means you're going to be multiplying. So this is negative 4 times 4, so that's v to the negative 16. The universe is losing their minds because of that negative, so we're going to take it and flip it underneath. 1 over v to the 16. Next up, negative 2 times negative 5, that's going to be y to the positive 10. So this topic actually goes by pretty simply the same way this one over here did. There's not a lot of bells and whistles, there's not a lot of extra thought. This, however, gets a little bit more complicated, enough so that I actually went through the effort of taking 6 examples instead of 3 or 4, because I want to make absolutely sure you understand. This is a DSA topic, and for a lot of students, they kind of struggle with this. Because of all of the negative signs, you can lose your place really fast. So, first thing is first, I'm going to put my exponent on pause for a second. I'm going to stick a pin in it, and we'll take a look at it later. First, I want to look on the inside. Any negative exponents I have, those I want to deal with. So we're going to deal with this first. So 3y to the 4th, those are where they're supposed to be, x to the 3rd. And then it's negative 3. The thing with the negative 3, that means I'm going to flip everything that is inside this entire parentheses. So I just went through all of that work just to take it all and flip it. So this becomes x to the 3rd over 3y to the 4th third. That is where students tend to get a little bit lost. So make sure you're doing it on, now that we're ready to unpause this, what you want to make sure, and I'm doing this in the wrong layer, gosh darn it, is you are taking care of your negative exponents, your negative exponents last, okay, and you're doing what's inside your parentheses first. That's what you're trying to shoot for. So now we're going to take this and distribute that cubed to inside everything. So x to the 3 times 3, that's x to the 9th. 3 to the 3rd, that's 27, because that's 3 times 3 times 3. Y to the 3 times 4 is y to the 12th. That will be your answer for this. All right, let's go through this again. I want to make sure you guys are comfortable with this. So it was 2b squared, c drops down because that's negative, to the 4th. Now this one's a positive exponent, so there's no extra step that I need to, that I need to worry about here. So I'm going to distribute the exponent now. So 2 to the 4. So 2, 4, 8, 16. So 16. B to the 2 times 4, which is 8. C to the 3 times 4, which is 12. This one, again, we want to be careful because we have that negative exponent, so we're going to put that outside one on pause, and we're going to look at this one first. So 4x squared, and then it's y to the 6, all of that to the negative 2. The negative is going to make me take my entire fraction and flip it, so it becomes y to the 6 over 4x squared, and then all of that now comes to the positive 2. Okay, that's a little bit easier to wrap our heads around. So y to the 6 times 2, which is y to the 12th. 4 squared is 16, and then x to the 2 times 2 is x to the 4th. All right, a couple of more. Let's see here. Negative exponent again, I want to handle that first. So it'll be 2w6x squared, all of that to the negative 4th. Negative there, that's what makes us going to flip our entire fraction to become 1 over 2w to the 6x squared, all of that to the 4th. So 1 to the anything power is just itself. 2 to the 4th power, so it's 2, 4, 8, 16. 16. W to the 6 times 4 is 24. X to the 2 times 4 is to the 8th. Now we're starting to get the hang of this, and we're getting a little bit more comfortable. There's my negative exponent. Flip where it is. So c to the 4th and b to the 3rd drops down. We have a negative 5. Negative means I'm going to take my fraction and then flip it. So it becomes b to the 3rd over 2c to the 4th, and then all of that to the 5th power. The act, I say it again, the act of flipping your fraction is what makes your negative exponent disappear. Now it's b to the 3 times 5, which is 15. 2, 4, 8, 16, 32. And then c to the 4 times 5, which is to the 20th. And also, IST kids, if you do not know your powers of 2, I very politely call shame on you and ask Mr. Buxton and Mr. Knuckle what your powers of 2 are, because wow, binary is a thing. So, negative exponent again. So we have 2z squared over y to the 3rd to the negative 3rd. The negative makes me flip my fraction, so it becomes y 3rd over 2z squared to the 3rd. Now we're going to take that and we're going to distribute it to everything inside. So y to the 3 times 2 is y to the 6. 2 squared is 4. Z to the 2 times 2 is z to the 4th. So I went through 6 examples at varying degrees of speed to help you guys figure out how to do these topics. Again, this one over here is a, which one was it? Power of a power. This one is a DSA question, and it can be very tricky, so you want to be very, very careful with it. All right, that's everything for now. I will have a new set of families to go through in the next video. I will see you then. As always, stay happy, stay healthy, stay safe.